So I just wanted to give you a little bit more practice on identifying the AXE form and the molecular geometry of some of the different molecules and the polyatomic ions. So I'll just go through some of these and I'll insert a few questions just to see how you're doing. So let's start and take a look at BF3. So for BF3, boron trifluoride, we have an AXE form of AX3. And AX3, if you look up here, is it says triangular. Sometimes we call it trigonal planar. And this is one of the ones that has an incomplete octet, so it's a little bit different. Remember, there are two, or actually three, categories of exceptions. One category are the ones that have odd electrons. All of the ones that you'll see like that are probably going to have nitrogen. Then you have some that have an incomplete octet, and those are going to be boron and beryllium compounds. And then you'll have expanded octets, and the expanded octets occur with the elements over on the right side of the periodic table when you get to the third level. All right, well, let's try another one. Let's try PF3. So for PF3, let's make that a little bit bigger. We have an AXE form of AX3E, and this unshared pair up here is keeping the other atoms sort of bent or out of the plane. So this one is called trigonal pyramid as opposed to trigonal planar. Okay, let's try something that maybe gives us an expanded octet. Let's try IF3. Alright, so for IF3, this is based around the ideal shape of AX5. That's where you have three pairs of electrons around the center here, what's called the equatorial position, and then the axial position, one up and one down. So this one is going to be AX3E2, and the shape for that one is T-shape. So AX3E2 is going to be T-shaped. Okay, let's try another one. Let's try ammonia, NH3. And ammonia is very much like PF3. We've got three bonding pairs, and like that, one non-bonding pair. So this is AX3E, and the shape for this one is trigonal pyramid. Let's try another expanded octet. So let's try I3 minus. So I3 minus has three pairs of electrons unbonded around the central atom, and then a bonding electron pair and another bonding electron pair up here. So the shape of that one is linear. And let's do CO2. So for CO2, you've got carbon, which has 4 valence electrons, and 2 oxygens. Each of the oxygens has 6. So that's going to be a total of 16 altogether. And remember that when you have double bonds, that you just count those once in terms of the AXE form. So this has an AXE form of AX2, and that corresponds to linear. So there are, quite a few different ones, but I think if you've made your charts, filled in those tables that I gave you, and you just study those, you should be fine.